Binomial distribution, or BINOMDIST. It returns the probability that the number of successes will be exactly x in n independent trials, where each trial has a probability of success m over n. So in this video, we'll generate the binomialist and use COMBINA to generate the same data set. We begin with the number of independent trials, data validation from the list 100, 200, and 300. Save. So we have three different values of the sample size. The successes from the list, that's 50, 60, and 70. And we have three possible successes. And the population will be 500. That's our total population. So we'll generate using the array formula. BINOMDIST of x, comma, n, the independent trials, and successes in the population. That's m over n. M over n. And we'll use the values 2 and let's say 60. And of course, because this is a probability density function or probability mass function, we use 0. And we can change the values. 100, that's the sample size. And let's say we have 70 over 500 success rate. So this is the probability density or probability mass function. We'll use COMBINA to generate the same data set. So we begin with the first term, COMBINA, array formula, COMBINA of n minus x. So n minus x plus 1. Oh, and x. So that's our COMBINA. That's the first factor. Times to the power x, m over n. That's m over n to the power x. So m divided by n. That's the successes in the population divided by population. Enter. So we've just entered the second factor, and the third factor will be 1 minus m over n to the power n minus x. So times to the power, so 1 minus m over n, success over the population, to the power n minus x. So n, the sample size, minus the success rate. Enter. They're exactly the same values. So we can change this to say 50, and we change the sample size to 300. So this shows the use of COMBINA array formula and data validation to generate the binomial distribution function.